Well, this series of videos is turning out to be quite long, longer than I expected. It's possible that some of you might be kind of skipping around and not watching every single section. So I really want to emphasize that this section of examples we just went through is maybe one of, or the most important section of the series of videos. Probably the biggest mistake that people make when they're drawing resonance structures is exceeding an octet. So what we've tried to get here is a simple and efficient and fast way to detect when you're exceeding an octet. Of course, one way to detect whether you're exceeding an octet is to always count all the electron pairs around every atom. But we really don't want to have a method that takes us that long, where we always have to count all the electron pairs. So here we're kind of trying to use a shortcut. So what's the shortcut? Well, first of all, we've seen that when we form a lone pair, we never have to worry about exceeding an octet. We've shown you an example that shows how when you form a lone pair, that can never exceed an octet. But we totally have to worry when we're forming a pi bond. You can easily exceed an octet when you're forming a pi bond, and that would give you a wrong arrow. But I think that we found a pretty simple and easy to apply rule to make sure that you are not violating the octet rule, exceeding an octet there. If you form a new pi bond, then you got to do it with a carbocation, or you have to do it with an atom that's also losing a pi bond. I think with practice, those are pretty simple things to check for, to make sure. So again, from now on, you have to be very careful anytime you see that you're forming a new pi bond. Make sure that you're either doing it with a carbocation or with an atom that's losing a pi bond. Remember that there is one more way to form a new pi bond. You can also form a new pi bond with an element that's in the third period or below. As we already mentioned, an element in the third period or below doesn't mind if it exceeds an octet. So that's actually a third way to form a legal new pi bond, with an element in the third period or below. But I haven't written that on the board because even though that's worth knowing for organic chemistry, it's much less important in organic chemistry than these two ways. Is this a legal electron-pushing arrow? Well, we're forming a new pi bond. That's when we have to be careful about exceeding an octet. Now, this is not a carbocation, so even though it has a positive charge, it still has a complete octet already. So this doesn't seem to have any more room for more electrons. And we know that this phosphorus is not going to be losing any pi bonds because it doesn't have any pi bonds. So it looks like there's no way to make this into a legal electron-pushing arrow. But actually, this is legal. This is legal because we're forming the new pi bond with a third period element. So remember that we briefly mentioned in the past that there is a third legal way to form a new pi bond. There is a third legal way to form a new pi bond. These are the main ways that you can form a new pi bond, but it's also okay to form a new pi bond with a third period element or below, because we know that we don't really need to worry so much about exceeding an octet for a third period element. It's allowed for a third period element to exceed an octet. So this arrow is allowable. We're allowed to do this. Even though the phosphorus already has a complete octet, it's okay for the phosphorus to have more than an octet because it's in the third period. So this is allowed. And this is actually an example that has some importance in organic chemistry. Usually this exception for third period elements isn't going to be too important to you, but this is actually important in the second semester of organic chemistry. This is what we call an ylide, and this is important in the Wittig reaction, which if you're in the first semester you haven't heard about yet. All right, but anyway, this is legal. So I did want to mention that even though these are by far the most important ways for forming a new pi bond without worrying about exceeding an octet, there is one more way that you're allowed to form a new pi bond. You can form a new pi bond with an element that's in the third period or beyond, even if that does exceed an octet, because third period elements are allowed to exceed an octet. So this again is legal because this is in the third period. Phosphorus is in the third period. This is an allowable arrow.